Dear viewers, today we are going to have a discussion on the basics of network criteria, structures, and physical topologies. What is the objective of this session? We will have a very basic idea about a network, then the network criteria, then we'll have a discussion on point-to-point and multi-drop type of connections. Then we will have a discussion on physical topologies like mesh, star, bus, and ring with proper illustrations. Now, what is a network? So, if we think on a basic term, the network is a set of devices which are interconnected through a communication link. Often those devices are referred as nodes. A node then can be a computer, it can be a printer, or any other device capable of receiving, sending a data which is generated by other nodes. Now, between the nodes, there are certain links which are established. Those links can be wired as well as wireless. Now, if we talk about the network criteria, what are the criteria that a network must fulfill? Is the first thing that it must fulfill is the performance. So it can be measured in many ways, including the transit time and the response time. Now, the transit time is actually the amount of time which is taken by a message to travel from one device to another device. And the response time is the time elapsed between an inquiry and a response. Now, performance of the network depends on many things. How many users are being connected to a network, what type of transmission link has been established between them, whether it's a wireless or a wired. Then what are the different capabilities associated with the network hardwares, and what are the efficiency associated with the software dealing with those things. Now, performance again most of the time evaluated by two metrics. We take it as a throughput and delay. Now when we talk about throughput, we usually send more data into the network. But what happens is when we send more data into the network, the delay increases. This happens because of traffic congestion in the network. Now, if there are less number of users, then the traffic congestion is minimal. But if we have a lot of users, the traffic congestion can be of a great cause of concern, and hence sending more data to increase the throughput can inherently increase the delay because of the traffic congestion. Now, let us talk about the physical structures. Now, the type of before that we will go on to understand the type of connections. Now, the first thing is the point-to-point, that is a single transmitter and a receiver. Then we have multi-point, multiple recipients of a single transmission. Then we have the physical topology, connection of devices, type of transmission. It can be unicast, it can be multicast, it can be broadcast type. Now, let us have a look at the basic understanding of point-to-point. Now, in a point-to-point connection between the sender and a receiver, there is a dedicated link that is established between them. The link again can be wired or unwired also. The entire capacity of that particular channel or that particular link will be reserved for the transmission between these two devices only. Now, we can have a example. We have televisions in our home, and to remotely operate the television by like changing the channels or volume or or the setting up the menus, setting up the picture quality, like increasing the brightness, increasing the contrast, or manipulating with other functions. What we do is we take a infrared remote, point it towards the television, and press the buttons available on it to communicate with the television. Here you can see we are establishing a point-to-point communication, point-to-point connection between the television and the remote. This is an example of a point-to-point type of a connection. Now let's have a look at the multi-point. Now it is also called multi-drop. Now suppose we have a link which is attached with a system which is the main system, and there are other ancillary systems or other systems which will be connected to this backbone. And in this single link, the other devices or the equipments will be connected in a shared mode. That is, the channel is shared. It can either be shared in spatially or temporally. Now if the device use the link simultaneously, we are actually having a spatially shared connection. And if the users or the nodes take time or take turns to access the link, then it is in the time shared mode type of a connection. Now let's move on to the next, where we study the categories of different physical topologies. Now here we can see there are basically four. One is called the mesh, the other one is the star, the next is bus, and then is the ring. So when we talk about the mesh, you can see we are taking an example of 5 nodes. Here it's written as station. So each of the node communicates with other 4 nodes. Each of the nodes are connected directly to a particular node. So if I consider the topmost node, it gets connected to other 4 using dedicated links. So here the hardware of the network interfacing is designed in such a manner that it is having communication ports which can be used to directly link the other nodes. So all the nodes are dedicatedly connected and in the point-to-point link manner. And in mesh topology, the number of links can be calculated using this formula, where n is the number of nodes. Here you can see there are 5, so this is 5 into 4, which gives you 20 by 2, which is the 10. So here are 10 dedicated links available. Now, what are the merits of this type of a topology? The dedicated links obviously guarantee that each connection carry its own load, and thus eliminating traffic problems. Here each and every node is dedicatedly connected in a point-to-point manner. So if a node A wants to talk to B, it talks to B only using their own channel. So if A needs to talk to C, then A and C uses their own channel. So here we can say that the data load and traffic congestion problems are eliminated. It is a very robust network, and a single point failure doesn't happen, because suppose there are 5, that is, let us consider the nodes as A, B, C, D, E. Now if A ceases to operate, then other nodes like B, C, D, and E can continue their own operation, because each and other nodes are connected directly to the other nodes, eliminating a single point failure. Now obviously the security and privacy of the entire system is comparatively very high. with the other physical topologies. And here the fault detection is also very, very easy. Now, what are the demerits? Now, it suffers from a huge demerit, that is, if we try to add another node. Here we were discussing about 5 nodes. Now, suppose I include one more node. Now the total nodes will be 6. So we need to connect other 5 nodes. So the particular node, the sixth node, should have at least 5 communication IO ports. Now, so when we increase the nodes, what happens is the hardware complexity of the system increases. And since we are having dedicated links, more wires, the bulkier the size, and sometimes it really becomes difficult to manage those wired links, and it is very costly. Now let us move into the star topology. Now in star topology, you have a central system which we usually can be used by a switch. It can be replaced by a switch or a hub, or you can also have a router. So in this, other communicating nodes are connected directly to the central controller, and the information is routed via the central controller. Suppose a station needs to communicate with the station D, so the communication will be established between the station A and B via the central controlling system, which is the hub. Now the star topology does not allow direct traffic between the devices, because this provides the intermediate stage via which the connections are established, so it can act as an exchange. Okay, the star topology is less expensive than a mesh, because suppose you want to increase another station, you just have to establish one more wire, and the connection is done. Then if we have less cable, the less cables are required, and there is no need for additional nodes, IO ports to be inbuilt in the nodes. So a single node can have a single IO port, and that particular IO port can be connected to the switch, hub, or a router. Now, if suppose the router or the switch port is less, then we can bridge it with another switch and then distribute the network. So it is quite possible in case of star topology to increase the number of nodes with less amount of requiring less amount of space, and also less on cost. Now let's have a look at this. What are the advantages? The advantages is it is again a robust network. You need less, it's less costly, and all the links remain active till the hub is active, and also in this case the fault isolation is quite easy. Now in case of the star topology, it suffers from a disadvantage, that is it's a single point failure. That is, if something goes wrong with the hub, switch, or the router, the entire communication system breaks down. So this is the biggest disadvantage in case of star topology. Now let's go and understand what is a bus topology. Now in this there is a backbone which is with a single link, and there are multiple taps where the nodes are getting connected. These are called drop lines, and this is the tap we can see, and there are 2 cable ends. So this is called the multi-point type, or the bus topology, and the wire here acts as the backbone for all the devices connected to the network. Now in this case, the taps can either be created using T, if we use coaxial cables, we can have a T to make a drop. In earlier days, the cable TV networks use this type of a topology where the physical backbone line, only one line was used, and those were provided taps, and those taps using T connectors, and the nodes, different televisions were connected using those T connectors. Now, what are the disadvantages with this? What are the disadvantages associated with this type of a topology? It's it's very difficult to for reconnection and fault isolation, and the bus is usually designed to optimally efficient at installation. So, including more nodes can be a problem. Then, then then from every tap, when a signal is transmitted from each and every tap, there is a reflection. So this can create noise and degrades the quality of transmission. Again, a fault in the backbone can stop all the transmissions, even between the devices which are connected. The damaged area of this particular bus topology can create a huge amount of noise to the other sections because of the reflection of the signals from the damaged area. Now let us move on to the next topology. It is the ring topology. It is the most easily connected topology, where we have a point-to-point connection with the two devices on either side of it. As you can see, there are 6 nodes connected. Each and every is connected with other 2 devices using a common link. Each and every node is connected via a repeater. Now, a signal is passed in this particular ring only in one direction. Is a unidirectional one from device to device until it reaches the destination. Now, suppose one of the node tries to send information to another node. So when the information is passed from the node which is not intended to receive the information or data, this particular repeater will repeat the incoming signal for the next one. And if again the next node is not the intended recipient, then again this repeater will repeat the signal, and ultimately the signal will be received by the intended recipient. Now, each device is linked only to its immediate neighbor. It is either physically or logically, and to delete or add devices requires only 2 connections to be done. But only constant are the media and the traffic considerations, the maximum ring length and the number of devices that can be connected. These are the only constants, because the rings can't be, we just can't keep on increasing the nodes. It increases the physical wire length. It also creates traffic consideration, and it also creates delay while reaching the far distant recipients. Now, fault isolation is pretty simple in this case. In this particular ring, a signal is circulated all the time, and if it is not received in a particular period of time, then the system raises an alarm, and the alarm alerts the network operators, which can to the problem and also to the particular location where actually the problem has occurred. Now, the only disadvantage that we can see in this is it's a unidirectional traffic. So a break in the ring can disable the entire network, since a signal has to travel in the ring. So any disturbance in the backbone of the ring network or the wire can actually disable the entire network. Now, this can be Now this can be overcome by using another ring, which is a dual ring, or we can have bypass switches which can actually bypass the disturbed node, and again the ring can start working. So this was all about today's session on physical topology network criteria. I hope the basic understanding of this, we had a very basic understanding of the physical topologies and the network criteria. Thank you very much for watching this video. We will have a look at the local area network in our next upcoming video on data communication and networking. Thank you very much.